Hello. Today we're going to be talking about a new class of games. I'm going to be going over the first game in Signaling Games Handout 2. So I would suggest if you could print out this game. You can find it at the bottom of the class's Moodle page under Class Handouts, and again it's called 2 Signaling Games Handout. So if you could please print that out before you watch the video. These videos correspond to Series 1 videos 18 through 22. So what I normally do in class, the material I'm going to present, I would be doing this in lecture, and the Series 1 videos 18 to 22 would normally not be required. They would be backup in case you missed a lecture or wanted more examples of what I was doing. But, because of what's happened, I think they're going to make it required. But essentially, you can think of the Series 1 videos 18 to 22, they're kind of in parallel to this. So you could watch those first, watch this first. They're just basically extra examples of a class of games. And I do admit these games are kind of complicated. This is perhaps the most difficult category of games I cover in class. And this is ultimately leading up to homework 7. So hopefully when you've watched the Series 1 videos 18 to 22, and then the videos going over the class note handouts that I'm going to start with this video, you will be able to do homework 7. And then of course after you do homework 7, they'll eventually be on Moodle. Perhaps there is now, depending on when you watch the video, there'll be answers, and hopefully you'll be able to see if you got that right or wrong. Okay, so let's talk about the game in front of us. So we start in the center. We start with nature. Remember, nature represents the random forces of the universe. Nature doesn't have a payoff. What nature has is probabilities. So we start in the center, and nature's going to move left or right. And this number tells the probability that nature's going to move left, and this number tells the probability that nature is going to move right. Since our probabilities have to add to 1, it's a good thing that this plus this equals 1. So if this happened to be 0.7, this would have to be 0.3. So nature decides, with basically a coin flip, to move left or right. Then player 1 moves. Player 1, there's no oval like there is around player 2. So there's no oval around player 1's decision node. So player 1 always knows exactly where she is. So if nature moves left, player 1 knows she's here, and she will never be here, and she knows that. So again, if nature moves left, player 1 will know she's here, and this will never happen. And of course, if player 1 is told that nature picked right, then player 1 knows she's here and will know she'll never be here. So if this were lecture, I'd probably have you be playing this game next to the person next to you, and I'd say, player 1, flip a coin. If it's heads, you know that nature picked left and you're here. And if it's tails, you know nature picked right and you're here. Okay, so player 1 moves, and player 1 is going to pick up or down. And player 2 moves. Well, there's an oval around player 2 here and here. Remember, if you're in the oval, you know you're in the oval, but you don't know where. So if player 1 knows, player 1 is told she's a lefty and then picked up, player 2 would be told, hey, you're somewhere in this oval, but I'm not going to tell you where. Similarly, if nature picked left and player 1 went down, player 2 would be told, you're somewhere in this oval, but we're not going to tell you where. So what this means is, player 2 knows whether player 1 picked up or down. Player 2 does not know whether nature picked left or right. So this game is meant to represent 2 types of player 1. So less abstractly, imagine that nature makes you either lazy or hardworking, and you know that. And you're a job applicant. Player 2 is the company deciding whether to hire you. Say X is hire you, Y is not hire you. So player 2 does not know whether you were hardworking or lazy, although you do. But then maybe player 1, up or down, could correspond to some action that you could take. So maybe up is going to college and down is not going to college. So in this model, going to college or not going to college would not be making you hardworking or lazy. You're hardworking or lazy before you made that decision, but it still might inform player 2 about your type. So again, can think of left or right are two different types of player one. Hardworking, lazy, honest, dishonest. Maybe has a car of high quality or a car of low quality. Maybe, going back to our Greek myths, is crazy, is not crazy. Is a girl, is the greatest warrior of all time. So nature creates, nature determines what type player one is. Player one definitely knows her type. She knows her type when she decides whether to go up or down. Then player two moves. Player two observes whether player one went up or down, but does not directly observe whether nature picked left or right, although maybe in some games, not always, in some games, player two can figure out from player one's move whether player one is a lefty or a righty. Okay, I think you have enough information to try and figure out this game on your own. So please pause this video and figure out what you think is going to happen. If this were a class, I'd have you play the game with a neighbor, and I'd say, hey, play the game, flip the coin, then switch who's player one, and do that a few times. So I guess if you have a family member you want to explain this to, you could play this game with your family member or whoever's in your household. All right, well, let's talk about this now. Normally, I want you to solve games backwards. That normally works. Unfortunately, when there's this uncertainty for the last move, backwards solving can work, but doesn't always. You see, normally when you solve backwards, it works well because you'd say, hey, this is the last move of the game if I'm here, so I don't have to care about the other player. I can just figure out what I should do what's best for me. Unfortunately, if your last move has this oval in it, you don't know where you are, you have to still think about the other player. What the other player did, is going to matter for where you think you are. So solving backwards can work, doesn't always, when there's uncertainty for the last move, when there's an oval around the last move, so you don't know where you are. All right. Let's imagine that nature picked left. Player one knows she is here. She knows she'll never be here. She knows she's here. Player one has to decide, do I go up or down? Well, player one will say, hey, if I go up, well, player two picks X, we'd end up here and I'd get 6. If player two picks Y, we'd end up here and I'd also get 6. Okay, I don't have to figure out what player two is going to do if I'm a lefty and I go up, because by this game I get 6 no matter what. Okay, it makes things a bit easier for player one if she's a lefty. What if player one is a lefty and decides to go down? Player one will say, well, look, if player two picks X, I'm going to get 8. If player two picks Y, I'm going to get 7. I don't know what my payoff will be if I'm a lefty and I go down until I figure out what player two is going to do, how player two will respond to my going down. Oh, and hopefully you figured out by now. Player one, if he's a lefty, will say, oh, you know what? I don't actually have to figure out how player two would respond to down if I'm a lefty to know that I really should go down. Because if I'm a lefty, going up, guaranteed 6. Going down is 7 or 8, both of which are bigger than 6. So if I'm a lefty, I want to go down, and I want to do that no matter what player two is going to do. And remember, when you want to do something no matter what the other player is going to do, we're going to call that a dominant strategy. So I'm going to put a D there. Okay, so we figured out we figured out if player one is a lefty, she is going to go down. That's going to help. Okay. Again, if you haven't figured out this game yet, maybe now with this hint, now try and solve it. Because this is kind of like skiing, this game theory stuff, where if I just talk to you about how to ski and you don't actually do the exercises, you're really not going to learn how to ski. So please, try your best to be doing these. Okay, now player one. Nature says she's a righty. You're a righty, player one. Player one will say, well, if I go up, I can get 10 if X is played, and I could get 10 if Y is played. Oh, well, I don't have to figure out what player two is going to do if I'm a righty and I go up, because I know exactly what I'm going to get. It's 10. What if player one is a righty and says, I'm going to go down? Well, said, well, I could get 2 or 3. I'm not sure which until I figure out how I think player two would respond to down. Oh, but guess what? I don't have to care when deciding what to do. If nature makes me a righty, I definitely want to go up, because up gives me 10 no matter what. Down gives me less than 10 no matter what. So this, if nature makes player 1 a righty, player 1 has a dominant strategy of up. Okay, player 2. Let's figure out what player 2 is going to do. Now, player 2 is going to be told whether player 1 picked up or down. Not going to be told whether nature picked left or right. So you're player 2, and you're told up. You said, okay, well, I'm here. If nature picked left, I would get 6 if I played X and 0 if I played Y. So if I knew I was on the left, I would definitely want X. Player 2 would say, well, if I knew I was on the right, X gives me 0 and Y gives me 3. So if I knew I was on the right, I would definitely want Y. So player 2 will say, if I'm told up, I can't figure out what I'm going to do until I guess what player 1 is going to do. And that, of course, means player 2, if up is played, does not have a dominant strategy, because you do not have a dominant strategy if your optimal move is a function of what you think the other person has done or will do. But, of course, as I hope you realize, player 2 will look at what player 1's going to do and say, wait a minute, if nature makes player 1 a lefty, player 1 is a dominant strategy of down. And if nature makes player 1 a righty, player 1 is a dominant strategy of up. And, we're assuming everyone's rational. If rational, you play a dominant strategy. So player 2 would say, the fact that I was told player 1 picked up, that convinces me that nature must have moved right. So even though player 2 cannot observe what nature did, player 2 can figure it out from watching player 1's move. So this is the equivalent of a sane and crazy Odysseus are going to do different things. So even though you don't know directly whether Odysseus is sane or crazy, if they always do different things, then once Odysseus has made his decision of whether to kill his son or not, you know what Odysseus's type is. So player 2 should say, if I'm told up is played, I am certain I'm here, given my assumption of everyone being rational, and obviously I would rather have 3 than 0. So player 2, if up is played, is going for Y. And you have to circle both Y's because, your strategy of player 2 is, well, if I'm in this oval, in this decision node, I'm going with Y no matter what. I don't think this is ever going to be relevant, but I am playing both. And I'm going to want you to circle what happens at every information node. Okay, now what if down is played? Let's see if does player 2 have a dominant strategy if player 1 picks down. Player 2 would say, well, okay, if down is played and I somehow knew I was here, X gives me 0, Y gives me 12. I want Y. If down is played and I somehow knew I was here, X would give me 12 and Y would give me 0. Now I'd want X. So if down is played, player 2 does not have a dominant strategy. Player 2 has to figure out what she thinks player 1 did. But of course, this is kind of easy in this game because player 2 will say, wait, lefty has a dominant strategy of down. Lefty is definitely going down. Righty has a dominant strategy of up. Righty is never going down. So if I observe player 1 going down, if player 1 told me, hey, I picked down, player 2 will say, I'm confident I'm on the left. And if I'm confident I'm on the left, well, my choice is between 0 and 12. The 12 obviously is better. So then we can finally figure out what's going to happen in this game. And there are 2 things that will happen because we don't know what nature's going to do. If nature picks left, player 1 goes down, and player 2 responds with Y, and we end up here. And if nature picks right, player 1 goes up, and player 2 picks Y, and we end up here. So there's a 50% chance in this game we end up here, and a 50% chance in this game we end up there. And this is the game. These games are going to get more complicated, but try and, if you want, you have the time, try and work through some of the other games on the class handout before we finish this video. Thank you. Goodbye.